Hey everybody, this is Larry, this is me going Q3 of the weekly contest for 5 count submatrices with equal frequency X and Y. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. This one, there are probably a lot of ways to do it. I just kind of did it I did it with prefix sum, but I don't even think you need prefix sum over this. Actually, maybe you kind of, I don't know if you do, but it is easier and that's the way that I did it. Yeah, so this is my code. This is prefix sum. The idea is going to be something that I'm going to draw to you. So hang on, let me bring up the technology. Right. So the idea here with prefix sum is just that for each character of X and Y, you have a matrix, right? The idea here is that this, you have cells, right? And the idea here is just summing up doing sums in a way such that, for example, this cell contains the sum of, let me change the colors. So that this cell contains the sum of this square, maybe, this cell contains the sum of all this. And the way that you do it is just basically with dynamic programming, which is kind of prefix sum. But yeah, but basically, for example, if you wanted to calculate here, this is just this thing, which is just the red one plus this extra thing, right? So that's basically the idea behind this problem, is just kind of creating these particular structures. And I have a helper class that does it for each character. So I do it for X, I do it for Y, and then I just loop through it so that if they're equal and if it's greater than 0, we increment because that's what the problem calls for. And yeah, what's the complexity here? Oh, and this is the prefix sum. There are a couple of ways to write this prefix sum. This is usually the way that I write it. You could actually put this inside here and it'll be okay. Right? Yeah, maybe. But this is the way that I always do my 2D ones. Like I said, there are many ways to do it. Some of them are, better than others, but usually not wrong. But yeah, if it's equal to C, then we increment. Yeah, so I get the X and I get the Y. So what's the complexity, right? This is going to be linear time, linear space, and yeah. Also, keeping in mind that linear is in the size of the input. The size of the input is R times C. And the complexity is going to be O of R times C time and O of R times C space. So linear time, linear space. You can actually do a space optimization here. So it's going to be square root of n space. Square space? Because you can notice that if you do them together and not have a helper, then you can realize that you only need one previous row, right? This only needs the previous row or the previous column, whichever one you want to optimize out. So then you can remove one of the dimensions. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve it live in the contest now. Got these. But yeah, 5. All right, let's go. Not my day. Return the number of submatrices to x, y, and at least one x. Okay, I mean just prefix sum, right? It's not that bad, but okay, let's do. I feel so dumb. That is such a silly mistake. Just watched it. I like to do it this way, actually. Easy. If I could type correctly. I don't know why I don't look at the constraints. I think that's an issue. Alright. Okay, that looks okay. Okay, so then now actually I don't even need a prefix sum, to be honest. I don't know why I did it this way. Now that I think about it. Yeah, I don't know why I did it this way, but that's okay. We're still gonna get it. Uh, 300, that is, ooh, 1. Really? Really? One. Oh, I am dumb. Okay, well, let's see what silly mistakes I could make now. That 5-minute pen. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.